All right, guys. One more video for chapter 2. Yeah, I know it's a lot. I think I feel. I've been doing this all in one sitting. All right, from start to finish. So we're almost done. And then we can, I guess, move on to the next chapter. So let's take a look. We are jumping into connective tissue. Connective tissues are weird. All your muscle cells kind of look similar. Your epithelial cells look similar. Your connective cells are drastically different. Like I feel like they just took everything else and lumped them together. Like they got lazy at the end and threw everything into one category. Because if you look at them, you wouldn't think they were the same thing. So your connective tissue include blood cells. This is actually a real picture in this we call a scanning electron microscope. This is a normal light microscope that we would see in a classroom. This big one here is actually a white blood cell. It only looks purple because of the dye. We got bone cells. Blood is connective, bone is connective. Remember, this is not the cell. This is a tissue. This individual black dot is a cell. Every little black dot is a different bone cell, and it is creating the white bone material, and it's kind of oozing or secreting that bone material out, and then it hardens and becomes bone. I forgot I had the zoomed in picture. So again, bone material is made in the black cell. It secretes out and hardens and becomes bone material. Then we got cartilage. Kind of like bone, but different than bone. It can be hard, it can be soft. It's going to be creating shapes that aren't needed for strong support like your bones. It's also going to be used for padding in between your bones. And they get kind of a glassy look, especially for the hard cartilage, like at the bridge of your nose. And fat is also connective tissue. And no, these are not bugs you're looking at. You're looking at individual cells, and this is computer-generated picture. I couldn't find a really good, detailed, real picture. But this is one cell. There's the nucleus, the endoplasmic reticulum, there's a ribosome, or that's the mitochondria. So we got all those organelles, and then everything else inside the cell is made up of fat. And the more you're going to store, the more it's going to get filled up in here, and these cells get bigger. So when you gain weight, you're not actually getting new fat cells. You keep the same amount of fat cells you have, they just get bigger. And the fat content inside the cells increases. So when you lose weight, it's these cells getting smaller. Here's what they look like in a regular light microscope, which is why I had to use a computer-generated one. The dyes do not stick to the fat very well, so it just ends up looking like white splotches. Again, and just a comparison, it kind of looks like the skin cells, the epithelial cells I showed you before, but here's your comparison. The dye actually sticks to the epithelial, so we can see the nucleus, we can get some details that we're not getting with the fat. That's how you tell them apart. And connective tissues, even though they have a lot of living cells, they're also made out of a whole lot of non-living matrix. Meaning a whole lot of this, remember this from the first part of these notes, we said the matrix is a whole bunch of non-living things used to hold you together, used to hold your cells together. A lot of them are going to be fibers, like your tendons and your ligaments, things that are actually tying you down and holding you together. Ligaments hold your bones together. Tendons hold your muscles to your bones. So just more fiber pictures here. In order to make those fibers, we're going to have a specialized cell called a fibroblast. This is a vocab word. Fibroblast. Fibro because it's making fibers, and blast is actually a stage of cellular development. Don't think of it that way. I always think of it as blast as it sounds like it's shooting the fibers out like Spider-Man's webs, right? It's blasting out fibers. It's a fixed cell, which means it stays in one place. It's not moving around your body like your blood cells do. And it's star-shaped. The reason for that is because the fibers, when they come out, they're pulling on the cell and stretching it. But it's also a really good way to tell what you're looking at. So you see here, this is actually what a fibroblast looks like when it's young, but as it starts making fibers and they're stretching out, they're pulling on the cell's membrane, and you get this stretched out star shape. Macrophage. The example I gave in vocab for this, this one is a blood cell, by the way. It's a white blood cell. And the example I gave was, I think, Bob the Blob from Monsters versus Aliens. You know, if you've never seen that movie, check it out. It's for kids. But that character, Bob, is this blob-like dude who engulfs his food instead of outright eating it. Things just get kind of sucked into him and get dissolved away inside his body. And that's what the macrophage does to your bacteria or viruses. If you get some kind of infection, these guys are going to come in and just eat them up, gobble them up. This is known as a wandering cell. I mean, it moves around your body. It's a blood cell. It's in your bloodstream, and is going to defend your body from these foreign things. This act of engulfing them, sucking them in, and dissolving them away is called phagocytosis. I've also heard it pronounced phagocytosis. Either one is fine, but I hear phagocytosis more often. Again, cyte, meaning have to do with cells. So remember that. Mast cells are located near blood vessels. They actually are blood cells themselves, a certain kind of white blood cell. We said in the vocab, they are going to be creating and releasing hormones, 2 specific hormones. I went into detail in the vocab, so I'll be fast about it here. They release heparin, which keeps your blood liquid. When you get cut and you bleed out, the blood loses its access to the heparin, and that's when the blood starts hardening. We call that coagulating, becomes a scab. They also release a chemical called histamine, and histamines only show up when you're breathing something you shouldn't be breathing, like pollen or spores, and you get an allergic reaction. Your nose gets all stuffy and clogged up. That is histamine keeping you from breathing. It's stopping you from breathing in the stuff you don't want to breathe. Our ancestors were nomads, I mean, they walked around. This was our sign to go someplace else. But we don't do that anymore, so now we got to go to the drugstore and buy antihistamines. Benadryl would be an antihistamine, and that will clear you up.
And histamine is great at calling in the cavalry. For one thing, it causes vasodilation, which creates redness and heat at the site of the injury. Now, those things might freak you out a little, but they're actually signs of healing. The increased temperature, for example, ratchets up the cell's metabolic rate so they can repair themselves faster.
All right, going back to connective fibers. Remember those fibroblasts that were creating different fibers? Let's talk about those fibers now that we're done with talking about the cells. We have different kinds. We have collagenous fibers, which it gets its name from a special protein called collagen. You may have heard of it as the stuff that you put in your lips. A plastic surgeon will put that in your lips to give you that big lip look. That protein in your body is actually supposed to be used to make these really thick, very strong fibers. We're going to find them in your tendons and ligaments. Like I said, ligaments are used to tie your bones together. So your femur, which is the bone in your thigh, and the tibia and fibula, which are the bones in your lower leg, are all tied together with ligaments. And then tendons are what's holding your muscle to your bone. We don't want those things to ever rip. They got to be strong or you're just going to fall apart. So collagenous fibers are the really strong ropes. And they're typically white in color. They're pink in this picture because we always use a purple or pink dye so we can see better. Then we got elastic fibers. If you look closely at this picture, you're not just seeing these really thick ones, but you're seeing these really thin ones as well. Elastic fibers are not very strong. They're not very thick, but they are stretchy. They are made from another specialized protein called elastin. Elastin has got that name because it's elastic or stretchy. And that's going to give you a little bit of give, right? You don't want to be just super resistant, super strong, because if you lose that fight, you rip and you're done. So we're going to have this elastic stretchy one to give us just a little bit of cushiony give so that we don't get torn apart. And they very quickly regain their shape. And it's going to be used in body parts that stretch around often, like your vocal cords are actually a type of fiber that vibrates as the air moves past them. More detail on that in a different chapter. We are going to see these as more of a yellowy color. Again, looks purple in here because of the dye. And then we got these reticular fibers. These things are kind of like a net, a mesh that's going to be used to hold things down. They're actually collagenous fibers, but most of your collagenous fibers are thick. These are very thin. They branch out to form this net-like network and is used to support your body parts, to hold you together. So they're going to be wrapping around things to hold you in place. Again, another picture of them. And this is a picture, typically if you were in class, I tend to give this as a coloring sheet, as a visual note guide. There you would color in the cell and the word in the same color. At the time of filming this, I'm not sure how I'm going to handle that through a virtual setting, but I will figure that out. Right. Moving on, categories of connective tissue. At this point, we've been going on pretty long. I will probably separate this out and turn the rest of this into another video. For now, take a look at Google Classroom and see if I left any work for you. Until then, see you for the rest of this video.